Welcome to lecture number 23. So to summarize the previous session, we had started the new topic called the direct form 1 and direct form 2 block diagram representation. Direct form 1 and direct form 2 block diagram representation can be applied for both continuous time as well as discrete time systems. In previous session, we could see how the discrete time systems can be represented using direct form 1 as well as direct form 2. Let me share my screen. In lecture number 23, we are concluding chapter number 2. The topics that are left to be covered in the session are block diagram representation for continuous time system. Discrete time system we have already covered. In the previous session, I had given you one assignment that is direct form 1. I had helped you regarding how to do it. So here is a direct form 1. So direct form 2, I had given it for you as an assignment. Now, quickly, we will just do direct form 2 by looking at direct form 1. So what we were doing in short method, so we were picking the first part and we are placing it in the second, and we were picking the second part and we were placing it on the first. Because the system holds good commutative property. The same thing we are doing here. I'll just show it here itself. X of n, and here it is y of n. So I am doing the direct form 1, direct form 2. Okay. So here x of n to y of n, I am just interchanging the system operator. So this part I am writing first. Let me write it. Summation. Then you have two shifters. Let me write it here. Two shifters. This summation I wrote. These two shift properties I'm shifting operations I'm performing. And then here the constant multiplied is 1 by 4. Here the constant multiplied is 1 by 2, and these two are summed up again, this one, and here I'm adding it. In turn, I'm adding it to the summation of the above one. So x of n is applied to this because this is replaced here. Now for the next one, we were calling it as w of n, intermediate. This was w of n minus 1. This as w of n minus 2. Now here, this part I need to shift here. If I write one more shift operator here, that's not right because that does not suffice the requirement of direct form 1. So direct form 2. Direct form 2 is advantageous over direct form 1 because it uses less number of operations. Here I'm having 3 shifters. Here I'm having 2. I can satisfy with only 2. So this shift operator here, one time it is shifting. So from here I extend a line. So the amplitude for it is 1, or you may write it or you may ignore it. Now directly give it to y of n. This is your direct form 2. That's it. So this part, see here, shifting is happening. This shifter, work is done by this shifter. So that's it. So this is your direct form 2. I hope the fundamentals of block diagram representations are clear for discrete time systems. We have a block diagram representation of CTS system, direct form 1 and direct form 2. We have the equation given in this fashion. The summation of AK and D by DKs, so it can be written as, let me write it here, A naught when K is 0, D raised to 0, dt raised to 0 means you don't write it at all. Just write y of t plus A1 d by dt of y of t. The meaning of this is A2 d by dt of d square by dt square of y of t. That's the meaning. So let us stop. Let us take k is equal to 0 till k is equal to 2. Let us take only 3 terms. Similarly, let me consider m also equal to 2, 0 to 2. So you can write it as b0 x of t plus b1 d by dt of x of t. This is a general form I am writing by this decoding this equation, plus b2 d square by dt square x of t. So this is your equation 1. Both mean same. Okay. So now to apply the integration operator to do this, because you have studied in the previous session that the shifter should be replaced with integration. That is what has been shown here. So here the maximum value of the order of this equation is n equal to 2. So I need to integrate it twice. So both whole of this should be integrated twice. So when I integrate it twice, how do I get it? I'll write it here. Then we'll compare with a general form. So if I integrate it twice, I get it as a naught, double integration y of t. Double integration y of t, I write it in this manner. What's the meaning of this? The meaning of this is double integration of y of t. It can be written in this way. Okay. So plus in the similar way, a1, one integration, one differentiation cancels out, one integration left. So we write it as one integration y of t. We can write it as one integration, one time integration y of t. That's how we write it. Plus a2. So 2 time integration and d square by dt square cancels out. So a2 y of t is left out. It's like 0. By default, it is 0, or else you may not write it here. This is equal to, in the same way, if I perform double integration here, I get it as b naught x of 2 means 2 time integration x of t plus b1 1 time integration of x of t, and b2 plus b2 no integration at all, because d square by dt square and it cancels. So I get this one. This is a very important equation, and general form of writing this is here. This I call it as equation 2. So here summation k is equal to 0 to n, 0 to n, ak means a0, k start from 0, y n minus k. What is n? N is 2. N is 2. 2 minus 0 is 2. Plus a1 when k is equal to 1, a1, y n is 2. 2 minus 1 is 1. 1 is here. Similarly, a2 y of n is 2. 2 minus 2 is 0. So 0 means y of t. Similarly here. So 1 to 2, if you want to come over this, you need to perform an integration. How many time integration? It should be equivalent to the order of the given differential equation. That is how you need to write. Once you get this equation, the things are very simple. So wherever you have y of 2, you need to write it as 2 time integration operator. Wherever you have y of 1, y1, it is nothing but 1 time integration. Wherever you don't have any integration at all, you just write it as y of t. Now what we are supposed to do is, I follow in this manner. So normally we consider in differential equation, normally we consider this a2 to be 1. Normally in most of the problems you can see that. Okay. So with that, if I want to write it, so this y of t, I write it here, y of t. This right hand side I call it as w of t, as we were doing in continuous time. So now what do you get? So w of t, this things, if I take it on the other side, I get it as minus a naught y2 of t minus a1 y1 of t. So this I call it as equation 1 or equation 2, because this w of t is equal to so and so. That is equation 1. That is what I write. W of t means what? All the input cases. b naught x2 of t plus b1 x1 of t plus b2 x of t. This is equation 1. So these two equations will help me in order to write the direct form 1. So what I supposed to do now? So I utilize the first equation for writing w by t divided by x of t. W by t, w of t divided by x of t is h1, and y of t divided by w of t is h2. Let me take that another slide. So w of t divided by x of t is equal to h1 I call. So this one can be written as, you just here, w of t, x of t, I need to take it on the denominator. What you get? B naught 2 times integration plus b1 1 time integration plus b2 no integration. So how to write it? So I write it in this fashion. B naught, in place of s I write integration. How many times? 2 times. b1, how many times integration? 1. b2, no integration at all. Similarly, I write it here, y of t divided by w of t. We call it as h2. The same manner how we were doing in discrete time systems. So equation 2 you refer y of t divided by w of t, or else I consider this equation, or I underline it, this equation. So y of t I'll take common, w of t I take it to the denominator. What do you get? Equal to 1 divided by, this goes to denominator, a naught 2 times integration plus a1 single time integration plus a2. So 1 divided by, the same manner, that's why I'm going quick, a naught 1 time integration 2 time integration plus b a1 1 time integration plus a2. This is h2. So you know that x of t is here. This is h1. You get the output as w of t, and I feed w of t as an input to the second system, and that will produce me y of t. So with this, we proceed with direct form 1 block diagram. The block diagram of the direct form 1 can be written as x of t is supplied to h1. h1, what does h1 does? h1 does 2 times integration should be there. So let me take that diagram. X of t is here. 2 time integration. Integration number 1, integration number 2. So b2 is without any integration. So I just pass it without any integration. This is b2. It's done. b1 with one time integration. With one time integration x of 1 of t. That's the meaning. X of 1 of t. Refer equation 1. Refer equation 1. b naught x2 of t. b1 x1 of t plus b2 x2 x of t. So b2 x of t is done. b1 x1 of t is done. B naught x2 of t is done, because here it is one time integration, two time integration. That's why I write it as x2 of t. And what is the constant to be multiplied to it? That is b naught. That is what I write it here. So all together I sum it, and here I could produce w of t. That is what is intermediate output. So once you get intermediate output, that you should feed it in the second system. In the second system, when you feed it, refer equation 2. Here, refer equation 2. So y of t is given by w of t minus a naught 2 time integration y of t minus a1 1 time integration y of t. Just here. W of t, feed it. There is no multiplication or multiplied by 1. Both mean same. 1 time integration past value of y1 of t multiplied with minus a1. The integration twice, constant multiplied is minus a naught. You can just cross check. 2 time integration constant is minus a naught. 1 time integration constant is minus a1. 1 time integration minus a1. 2 time integration minus a naught. Sum it and put it here. So that gives you the direct form 1 of discrete continuous time system. Now for commutative property, take this, commute each other like h2. Write h2 first and then h1 later. Or else just pick and place. Take this and put it here. Take this and put it on the other side. Two integrations are there. So with only two integration and four summations, we can do the further process. So direct form 1 can be achieved as x of t in the same place. So here place h2, which will result in w of t, and here place h1. So that will give you y of t, because this holds commutative property. Okay, so that's the reason. So with this, we get the diagram like this. You can just carefully observe. So you just cross check here how this block diagram is formed by picking and placing. So this part has been placed here. This part has been placed here. That's it. You can just cross check. Summation, 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 minus a1, minus a naught, minus a1, minus a naught, two integrations, and that's it. So go for this part. I'll place it here. Integrations are already done. Just put the constants b2, b1, b0, b2, b1, b0, summations, and your things are done. That's it. Either you can prove it like h2, write w of t divided by x of t, which is equal to h2. h2 is already pre-written in the previous slide. That is, I'll show you. Here it is h2. You can write it as well as and cross check it. So here I can write it as b naught integration 2 times plus b1 integration 1 time plus b naught, and just cross multiply with w of t, x of t comes over here, just check it out. So it will result in the same answer. Either of the way you can prefer. Okay, so this is the simplest way of solving direct form 1 and direct form 2 of both continuous as well as discrete time system. We will have one or two problems in order to get comfortable with this problem. So I'm taking one of the equation, giving one of the equation. Let me call this as equation 1, differential equation. We have to form direct form 1 and direct form 2 representation. The very first work is, this is a differential equation, so I need to take double integral of this. Take double integral on both sides. So when you take double integral on both sides, what do you get? Double integral that cancels with double differentiation. You get y of t plus 3 into y of t. Double integral is there. So hence, rather than writing two double integrals, I write it as y2 of t. Both mean same. This is equal to double integral and single differentiation. Only one integral left out. So you write it as x single integration of x of t plus double integration and double differentiation cancels. You get only 2 into x of t. This is my very important equation. Equation 2. Once you get it, so take the input side as w of t. I'll write it here. W of t is equal to x1 of t plus 2 into x of t. And similarly, if I write w of t here, so you get it as y of t plus 3y2 of t is equal to w of t. With this, I can write y of t as w of t. This I take it on the other side, 3 into y2 of t. So this equation and these two equations are very important. So here, so I'll show it here. W of t divided by x of t can be written as h1. So that can be written as, when x of t is taken common, so you get it as one time integration plus, and there is no amplitude here, so I write it as 1 plus 2. That's it. This is h1. Similarly, here if I want to write the equation, so I refer this equation. So I get it as y of t divided by w of t. We represent it as h2, and what is left out here? Y of t, if I take common, so 1 plus 3 double integration will be left. That I have to take it on the other side. So to form y of t divided by w of t, so hence it will come in the denominator. So you get it as 1 plus 3 into integration twice integration. So these are the two equations, and you have to form the direct form 1. Direct form 1 is x of t, input is fed to h1, you get it as w of t, that is in turn fed to h2, which will result in y of t. Now with these ideas, we will build a direct form 1 representation. So first thing, so x of t I write it here, y of t I write it here. Okay, so x of t, refer h1, h1 is formed here, h1, this equation, 2 into x of t means x of t, you take it, you should multiply it with 2. That's you are done with the first term. This term is done. Now for this term, to generate this term, I have to take one time integration, then I get it as x1 of t. So for this, what is amplitude? Amplitude is just 1, scalar multiplication. Now these two things should be added. So add it, you get it as summation. That's it. This is w of t. This equation is done first. Now we will follow this equation. Here y of t is can be got plot by w of t. W of t is as usual there, and its amplitude is 1 because your amplitude is 1 here. Now this this is minus 3 y2 of t, to double integration of y of t. I take double integration. First time integration will result in y1 of t. Second time integration will get me y2 of t. Y2 of t. So this y2 of t is constant as minus 3. So I have to add it with this one. I have to take a summation here. Okay, so add it. So that will generate you y of t. This is direct form 1. I hope there are no doubts. The direct form 1. So direct form 2, interchange it. Bring this on the left hand side, take this on to the right hand side. That's it. We'll do it. Or else you can interchange h1 and h2 both. So let me write h1 and h2 for your reference. So y of t divided by w of t, it is actually h2 of t. So here what we do is, this one should be, because I write the block diagram, h2 first, h1 next. This is y of t, this is x of t, and intermediate is w of t. So this is how the equation is. So h2, this y or y of t divided by w of t is h1. So what is h1? Copy the h1 of previous slide. H1 is one time integration plus 2. One time integration plus 2. And similarly, if I want to write the w of t divided by x of t, it is equal to h2. So what is h2? Refer the previous slide. h2 is 1 divided by 1 plus 3. 1 divided by 1 plus 3, 2 times integration. So with this, you can generate the equation by yourself. So let me write it here. Y of t is equal to w of t, take it here. 1 into w of t, one time integration means I have to write it in this manner, plus 2 into w of t. This equation is done. I name it as a1, and here keep your w of t as it is here. Take x of t, uh, w of t. So here 1 plus 3 integration, double integration. This is equal to, take x of t on this side. So you get it as w of t plus 3 into double the integration of w of t. This is equal to x of t, and w of t is given by x of t. Take this on the other side, 3 into integration of w of t. So with these things, this and this, I build a direct form 2. So direct form 2 is x of t on the left hand side, y of t on the right hand side. So x of t with I can say amplitude 1 should be added with, what? Should be added with w of t, but not w of t. It's a integration of 2 times integration. So let me take integration first. Integration one time, integration second time. So this is w2 of t. This is w1 of t. I need w2 of t. What is the constant? Constant is minus 3. So add it to this. So this will generate the w of t. W of t is nothing but x of t. X of t is there, plus minus 3 w2 of t. Minus 3 w2 of t. So this will give me w of t. Now y of t. Refer the a1 equation. This I call it as a2 equation. Refer a1 equation. So y of t is got by one time integration w of t is already here. One time integration w of t is already here. Take this. What's the constant? Constant is 1. Write it. Next, 2 times w of t. 2 times w of t is, that's it. 2 into w of t. 1 into one time integration of w of t. Both should be added. This will give you y of t. This is direct form 2. Very simple. So this completes your direct form 1 and direct form 2 block diagram representation. So here it is there for your reference. I just erase it just for your uh, having the neat architecture here. Okay, you can just refer. So this is how it looks. In the same, it matches the diagram that I had drawn just now.